here's my contact information. What I'm going to talk about today is, let me give you a little bit of background about myself. So I've been writing software for about 18 years commercially. The last 7 or so has been all mobile. Includes a lot of iOS app a few years ago. And most recently, it's been all Android applications. And when I was asked to do this talk, they asked me to do this talk, I was given some choices on kind of what to speak about. And I decided that the easiest thing to speak about is to give you kind of some insights into kind of how we currently, the New York team's currently developing Android applications. So this is really kind of a distillation of our best practices. And in the last 6 months, we've worked on two apps. I'm showing them here, Automatic Call Recorder for Me, which is in the store, and Coloring Book for Me, which we're just finishing up. So it should be released anytime. It's in kind of final testing. And so what I'm really going to go through is just go through kind of how we develop applications, how we think about developing applications, give you our current best practices. And of course, I'll try to go fast because I have a ton of stuff to cover. Take questions. So get feedback. Okay, so before I kind of get into my actual talk, we have an announcement to make, so I'm going to go through this announcement quickly. Today we're announcing the release of our translation tool. So we've developed a translation tool. We're open sourcing it, and what it does is dramatically simplifies the creation and management of string files for Android. And what it's based on is you create a Google spreadsheet, put all your translations in the spreadsheet. We've created a Gradle plugin, and you simply type this Gradle command, update translations, and it will automatically pull all the data from the spreadsheets, create all the strings files for you. It's been a super time saver. We've been using it for about a year, and it's if I have time at the very end, I will give you a quick demo of it. But it's literally like 4 lines of Gradle code, and you run this command and set the spreadsheet up. That's it. That's all there is to it. It's a fantastic tool. It's being made available today. Like I said, if I have time, I will go through it at the very end. Okay, let me talk about my agenda, and then I'll start going through it. So the first thing I want to talk to you about is clean architecture, or architecture in general. Okay, why do I care about this stuff? Why do I think it's important? Again, this is a very pragmatic approach. This is the way I think about it as someone who develops software and manages teams of developers who make software. So I'm going to go talk about why I care about this stuff. I'm going to talk about app organization and naming, because I think this is an area which is often underappreciated. People don't spend a lot of time thinking about how we should name our apps, what kind of packages we should create, and I think it's really important. So I'm going to talk about that. I'm going to give you just a quick rundown of our processes and libraries that we use, key libraries. And this is really just because I get asked about this stuff a lot. I think most people are interested in kind of what are you guys doing? What libraries you use? What process do you use? And so it's going to be a quick rundown of that. And then I'm going to spend most of the time talking about reactive programming. So for us, the last year, the biggest change in how we write software has to do with reactive programming. Right? We started implementing and using reactive. Now, pretty much all of our data is set up as observables using reactive programming. And I'm going to try to give you some insights of why we did that, what do I think the benefits are of reactive programming. Yeah, so that's going to be the last thing, and then I'll hit questions. Okay, let's get started. What do I mean by architecture? And then specifically clean architecture. Okay, so for me, architecture is basically how you organize your code, including naming conventions, package organization, libraries chosen, design patterns used, and the structure of the source code itself. Right? So it's really comprehensive. Almost everything we do in software, at some level, it has to do with architecture and how you cut things up. So it's important. I'm going to talk about that a little bit. I'm not going to get down kind of to the level of the structure of the code and the details. If you're interested in that, Jorge had a great workshop this morning to kind of go into that in detail. There's no way I can cover that in 40 minutes in the first place. And I have too much other stuff to talk about, so I'm not going to even bother. I'm just going to skip over that and hit the highlights of the other things. And by clean, I mean this in more of a generic sense, okay? For me, clean means it's organized. It's tidy, it's understandable, it's clear what you're doing, okay? So if we put these, and I'll put one more term out there, which means modular. For me, clean and modular are very closely related. And I think if you went to the workshop this morning, you'd understand why that's the case. So I'm not going to go a ton of time into that. I just like to define these things so we kind of know where I'm coming from, what my perspective on this is. And I put a couple of useful links. You can take a look at them. And that's it. Okay. Let me talk about the benefits of clean architecture. Clean architecture, for me, has three very practical benefits that I see, and I think it's really important. One is it's easy to understand. At the most fundamental level, if you're an engineer and you're on my team and I give you our code base to work on, I don't want you to have to spend 3 or 4 days just trying to figure out what's what. It should be pretty obvious, you know. If I ask you to fix a feature, you should be able to go to it, find the feature, and get to work. So that's what I mean by it's easy to understand. Easy to refactor. I think this is really, really important in software. We refactor a lot when we're writing software. And if your software is hard to refactor, it's hard to debug, hard to fix, that's a major problem. And the last one I think is just as important, is you want something that lots of engineers can work on at the same time and not end up with these horrible Git merges at the end. So here's my kind of practical tips I'm just going to give you on this, and then I'm going to go into some detail on each one of these. Practical tips for clean architecture, and this is a very pragmatic approach. Organize your code, use good naming conventions. I'm going to talk about that. I think it's important. No one talks about it, at least not very much. I'm going to talk a little bit about making your code modular. This goes with one of the main reasons we moved to reactive programming. It helps a lot. It's a very good tool to help you move in this direction. So I'm going to talk about that. And then this whole concept of less is more. We have some great libraries in Android. I can mention a couple. You know, for example, a butter knife just saves a lot of boilerplate code. Doesn't really do anything, but saves a lot of boilerplate. It's very clear what's going on. Those type of tools are helpful. If you have to write less soft code, you have less stuff to maintain, you're probably going to have less bugs. And then using consistent design patterns. Don't use, look, if you're using Model View Presenter, use Model View Presenter. Don't start mixing and matching all these different design patterns, especially if they're large design patterns. It makes your code very hard to understand. So, all right, so let's go in. Okay, so I'm going to, let's talk about naming and packages. I'm going to just give you a quick demo to try to make this a little bit more intuitive for everyone. All right, can people see this? I hope it's not too small. All right, you probably have no idea what this is, so I'll explain it to you. What I did is I took our current code base, release version, ran it through a tool. We use ProGuard, which basically strips out names, classes, all the naming information, right? And I said, okay, what does that look like? I just went through, ran this little tool, shows me what it looks like when ProGuard's done with it. Shows me a class, which I wrote. I have no idea what class this is. I have no idea what it means. I have no idea what it's saying. I could probably figure it out if I spent, 15, 20 minutes. Actually, the only real hints I have in this file are things that we told ProGuard, don't touch. If I told ProGuard, we have this data class, I don't want you messing with it, and we have this item class, which is that way, I understand that's an item. That's a good clue. But everything else is like, okay, I have no idea. And the reason I'm bringing this up is just to say naming is really, really important, right? If you don't get your names right, if you don't self-document your code, managing it, changing it, understanding it is really difficult. And at least when I was doing computer science classes, none of my professors spent much time on naming. It was pretty much call it whatever you want, don't think about it too much. I think it's important. That's why I'm raising the issue. Okay, let me give you one more example. Hopefully that will help. Okay. Or at least show you what I mean. All right, this is basically our app. And I'm just going to talk about it very briefly. Again, this is in the context of if you were on my team and I wanted you to do something, if I told you to do something in this app, so for example, here we're in the gallery view. we have a gallery view. We have different images you can color. This is our coloring book app. If I said, work on the gallery, and I gave you my code base, could you actually do that easily? Could you understand what's going on? Could you find these things? I can tell you I've worked on some code bases in the past where that would have been a challenge, right? I would have no idea where to start when I looked at the code base, right? We have this edit function, right? It brings up a color wheel. I told you to work on the color wheel. Could you find it? If I told you to work on the edit screen, could you do that, right? If I told you to work on the palettes area, could you do that? So these are very basic things, right? And to some extent, your code base should be reflecting your application. So someone who has it and is working with it understands what your code base is saying. All right. So, so if I go from there, let's see. Sorry about that. I move this around, so all right. Let me. I was actually writing some software this morning, so I kind of messed this up a little bit. But that's okay. We'll go with it. Can people see this? Or is it too small? Okay. I will try to make it bigger then. Is that better? Yes. People see that? All right, so this is our code base. It's got a few changes because, like I said, I was editing it this morning. But I think the whole point of this, I'm just going to collapse these. This is the coloring book code base. Some of these things should be very obvious. If I said work on the gallery, for example, we have a guide gallery package, right? You should be able to understand that that's what we're doing. You probably could guess that we use a model view presenter here as kind of our basis for architecture or one of our design patterns, because we have something called model, something called presenter, something called UI, right? So again, this goes back to the point I'm just making about naming. Name things, make them easy to understand. That's one of the points of a nice architecture, right? We have the same thing with edit, right? We have this edit, or you can go down to palettes. It's the same. We use these same patterns over and over again when we do naming. And it's because I care about these things. I think it does make a difference. Okay. Let me jump back to the slides so I remember where I'm at. All right. So that's my little talk about naming. I'm going to next jump into processes and libraries. And this is really just a very quick rundown of this. I'm not going to go through these in detail, although if you have questions, I'm happy to answer them. Process, we use agile 2-week sprints. Android Studio, we tend to stay pretty close to the bleeding edge. On Android Studio, we think taking advantage of those features is usually important. Gradle, we use it extensively, not just for dependency management, but for other things. As I said, we created a plugin for Gradle to improve how we deal with translations. Git, we think it's the best source code management system. We use GitLab as our actual place we store stuff, and we use Jira for tracking everything. So those are kind of our tools of choice. Process, I'm sure there's other great ones out there. Libraries, Butterknife, we pretty much use it for everything. OK, HTTP3, Retrofit, and Picasso, that's pretty much how we connect with servers, depending on the circumstances, but those are kind of our tools of choice. Reactive, I'm going to get into that. These are kind of our reactive things that we use, all the libraries. I will give a shout out to RX Preferences, really nice library. More or less has replaced all standard shared preferences for us. We always use RX Preferences now. And then there's some other ones, Stetho, Leak Canary, great kind of QA tools. And then we have our translation tool. So, okay, great. So most of the rest of this talk is going to be about reactive. I'm going to talk about it. Why is it? Why I think it's important. Why I think you should strongly consider adopting it. Before I go into the benefits of it, I want to talk about costs, because there are some. So there's no free lunch with coding, and Reactive has some. One, it's fairly difficult to pick up. It's a very different way of thinking about programming. So first, before I get into this, how many people are using Reactive right now in their applications extensively? Okay. How many have some understanding of it? Okay. All right. So hopefully what I'm saying for you people who are using it a lot, it'll highlight a few things. And for those who are considering it, it'll give them a kind of a reason to keep pushing on it. So first of all, there is a substantial learning curve on Reactive. I don't think anybody who's started working with it in 2 weeks has picked it up and understands it fully. Right? I've been working on this for over a year now, and I'm still learning stuff about it. Right? So second, since it's a very different way of thinking about programming, it clashes somewhat with the existing Android APIs. And you sometimes have to make a decision. Is it better to use Reactive and do the reactive approach, or is it better to stick with the standard Android API? Right? A good one would be how you handle touch or click listeners. There's a reactive way of doing it. There's a standard way of doing it. When do I use which one? You got to make decisions about that if you move to that. That's what I mean by a clash. And finally, the way Reactive works means that you always have this issue where you have to make sure you're unsubscribing at the right time. Otherwise, you will have memory leaks. Right? So these are kind of the kind of risks that you have to manage if you're going to move to Reactive. I think it's worth doing, but I wanted to point them out. Okay, so let's go. Benefits. For me, Reactive combines really 3 compelling features, or 3 compelling things that make it a very nice technology, make it worth moving towards. First is it uses the observer subscriber design pattern, which I'll go into each one of these. Second, it has very, very nice and elegant thread management. And the third thing, it has very, very powerful operators to transform and control how you admit data. Okay. Let's talk about the observable subscriber pattern. So Reactive is based on this concept, this pattern of observable subscriber. Observables are basically have a one-to-many relationship with subscribers. So you can think of this almost like a listener, right? You have a listener or observer. But there can be many classes or objects listening to the changes. And every time there's a change to the observable, a state change, all the subscribers will get notified automatically. Here's an example of that. So if we have this method get images, you can see it returns an observable, which has a list of items in it. All right, so that's to be the get messages. Then you can have a subscriber object. So on the other side, you have this object that's subscribing to this observable, and it will get notified when there's a change. And so again, in the last line, there's this example where you get the observable using the get images is above. You subscribe to it. You get this list of images, and then you do something. So this is just kind of the standard pattern. Standard way of thinking about observer subscriber. This is very powerful, and I think if you just think about this for a minute, you'll immediately see why this helps make things more modular, right? Because you, in essence, have now a very clean way of separating how objects communicate, right? So you think about it. You can say, I have this data object, let's say it's a preference or it's a database, and it's now providing an observable, right, whenever there's a change to some kind of data or some table in a database. Whoever wants to know about that, all they need to do is get this observable, call that method, they subscribe to it, they will get notified whenever, right? So you've now decoupled these substantially. It's very helpful. And I just want to touch on lifecycle. This is a little bit kind of getting into the details of this, but I think it's important for those who haven't done much Reactive to kind of see exactly what's going on, what observables actually are doing, take some of the mystery away. So you get this observable, you create it. When you subscribe to it, there's this callback that happens, this callback that happens to it, and the observable then does one of three things. It calls on the subscriber. It either calls on next, which means I have some data for you, calls on complete, which means I'm all done, or it will call on error. And that's really all it does, right? So it's very simple. It does one of these three things. Whenever you do create an observable of all types, and as you'll see later on, they can be quite complicated. You can do lots of interesting things with them, but they're always doing the same thing. They're just calling on next, on complete, or on error. So I just wanted to bring that up. So as I keep talking, you'll keep that in mind. Okay, so let me jump. That's kind of the observable subscriber pattern and why I think it's useful. Let me jump into the standard, talk about thread management. Compared to standard Android threading technologies, Reactive handles threading in a very elegant, simplified way. Now, I will say there's lots of ways of doing threading in Android. In different circumstances, you'll use different things. And I'll just go through a couple of them. We have a handler, very useful, right? Create a handler, object, create a thread. You call the handler when you need it. This works great. It's a little bit of boilerplate. It's fine. It can be a little bit hard to read because often you're calling this handler in a very different part of your code. But this works okay. Or we can do async task, again, great. Async task is great. You can do something in the background. You get these callbacks on the thread that calls the async task. Again, this can be done. There are already some issues with async tasks, dealing with life cycles. But again, these are different threading tools, techniques that we have in Android, and they can be appropriate. They can be very effective. Again, but if you compare this to what you do in Reactive, you can see Reactive is just very clean, very simple, very straightforward to think about. So here's a piece of code comes out of our coloring book app. We have the service, coloring book service, which is querying the internet for a list of images that are available for coloring. Thank you. And we call it, and then we have this thing, get coloring book data, right? This returns an observable. So this returns something that we can watch and observe. And then here in this case, we do the dot subscribe, right? Which is where we're actually going to do some work on this information that comes back from this internet server. All right? So that's basically everything. But then we added 2 lines of code, subscribe on and observe on. And this basically handles your threading for you. So we're saying, and we can specify this, in this case, we're going to subscribe on the scheduler's IO thread, which is a thread pool, when we're subscribing. And we're going to observe on the main thread. So all we have to do is add these 2 lines of code, and we can basically manage our threading as we're communicating with the server. This is very straightforward, very elegant, very easy to change, right? We can just switch threading at any time with one little line of code change, and our threading of our app changes. Compared to those other techniques, if you're using this to manage how you communicate with all your data sources, you've got, even if you have 5 or 6 different data sources, it's only 5 or 6 places you have to manage all your threading of your application. Right? It's just very elegant, very nice. For me, it's one of the things I like best about moving to Reactive. It just really simplifies thread management. All right, the last thing I'm going to talk about when it has to do with our kind of overview of Reactive, it has to do with operators. Okay. So this is, again, a little bit of a different term, right? RXJava supports many operators. Most operators take, not all, but most of them take an observable as an input, return an observable. This allows for chaining, so you can basically put multiple operators together. For example, you can have merge and filter. You could have a merge operator that merges some data together. You could then filter it using a filter operator. And this allows you to very easily and elegantly control how data is combined and admitted, right? And here's an example of that. So this is an example, again, I pulled it out of our coloring book app. And it has to do with images. So we have an image that you can color in our coloring book app. And we have this concept in the application of a premium image, right? A premium image is an image that you need basically to subscribe. We have a subscription service with this application, and if you subscribe to the application, then you get additional images available to you to color. And this is basically our check that we use to determine if an image is premium, and if it's unlocked so you can actually color it, right? And we have basically three things being done. So we're using this thing, observable.combine latest. So we're doing a combined operation. And below it, we have basically the three things we check. First is a preference, is called is premium. Again, and we are doing an as observable, which means you get an observable of this. This is a preference. It basically tells us whether or not they have a subscription. The second is whether the image itself, and then here we're using observable.just, if the image itself is just a free image. It's not a premium image anyways. And the third one is to check if it's a reward image. So we have this concept in the application of daily images, and we offer one image a day, premium image a day that you can get rewarded to you if you watch a short advertisement video. Watch the video, we'll say, okay, great, and then we'll just make the image available to you. So these are just little features that we have in our app. Anyways, the point is this is a very easy check. We get these three observables, we return an observable, right? Which is a Boolean, which is kind of the combination of these three. If any of these are true, if it's available, then it's true, otherwise it's false. Super simple, nice way to combine stuff. It's easy. Let me show you kind of the list of operators that are available, because it's a large list. To give you a better sense of what you can do with RX. All right, so this is just a list of the things that are available. And you can see there's a lot of things you can do, right? You can average, you can block, you can buffer, you can cache, you can collect, you can concatenate. There's a very long list of these operators, which then you can, and most of them, again, have this chaining ability where you can chain one on top of the other. You can filter and then combine, or combine and then filter, and et cetera. Again, this is a very powerful feature of RX. And was one of the compelling reasons why we've moved strongly towards it. Okay, so let me just summarize. And this is my general summary of RX and why I think it's great, and you should strongly consider using it. So RX combines three features of this observer subscriber design pattern, which tends to lead to more modular code, makes it much easier to separate things. Very powerful thread management and elegant thread management that's cleaner, easier. And then these powerful operators to transform data in a clear way, makes it easier to manage and control data. All right, so let me just summarize. So that's kind of my summary or my pitch of RX Reactive and why you should consider using it. Let me give you these are my practical tips. So these are kind of our current best practices and how we use it. And there's many more. I summarized kind of the highlighted, the main ones we use. First, in both Call Recorder for me and Coloring Book for me, pretty much all data, from shared preferences to how we communicate with servers, to how we pull stuff off of a database, to how we pull stuff off of disk, all uses reactive programming. We just simply expose observables. That's what we do. This is pretty much a pattern we use on everything that's actually a data resource. Second two have to do with the issue of when do you unsubscribe from an observable? When do you subscribe to an observable? And the reason this is important is because when you subscribe to something, you're basically implicitly passing a reference to that. And if you don't unsubscribe, you will leak, right? You have this reference, it will never get freed, and you will create a leak. This is our basic practices for dealing with that. On activities and frameworks, we always subscribe on resume. We always unsubscribe on pause. There's a few exceptions, but pretty much across the board, that's the rule that we use. For presenters, right, where we've got this view, and the view itself is kind of the main thing. We use unattach to window and detach from window. So same logic. That's how you're sure you need it. You're attached. That's when you're sure you don't need it. You detach. So those are kind of our tips for that. Here's some links. So I'm just going to give you a bunch of links. If you to learn more about RX, you can take a look at the links. And I'm going to jump in. Maybe we should do what we should do with this. I have time. Do I have time? I have time. I could go through the text tool right now and then do questions, or I can do questions first and then hit the text tool. Why don't we do questions first? Because the text tool is really just a demo, right, of how you use our text tool. It's going to take about 5 minutes. So why don't I take questions? There's one back there. Good point. The question is, how do you debug reactive programming? Yeah, I almost put this as a cost of reactive, because this is one of the areas that we found can be challenging on the data side. And the reason, let me give some background on why it's a challenge. And let me just say, we don't have a great debugging solution, right, for this piece. So if someone has one, I really want to hear about it, because we struggle with it. And the reason it's hard is the power of these operators. Often what you're doing is you're combining, filtering, etc. You've got 2 or 3 or 4 of these things chained together. And the problem is each one of those is basically a black box to you, right? And all you can tell is what came into one, and then one goes to the next one. And our debugging strategy is basically we peel away. So we try to validate the first layer, the first operator works, then we validate the next operator works, then we validate the third operator works, right? But that's the only way we know how to debug. We basically turn things off and just see what the data coming out is and make sure, oh, that's right, it's correct, it's working in all use cases. Do the next one. And that usually allows us to kind of figure out, oh, we're actually using the wrong operator. That's usually the problem. We're using the wrong operator. And I will say, one of the issues I have with some of these operators is they're just not always named real well. Like they have the zip operator, for example. Okay, so if I told you zip, and I just said it's a zip operator, I'm not sure most people would say, I know what that does. You know, that's clear to me. Filter's usually pretty clear, right? You get this area where you can basically write this little function to filter something. That's usually pretty clear. But some of these operators are very kind of obscure, and you have to look them up and research what's going on to understand them. But that's a great question. I don't have a great answer. If someone has one, please let me know. Other questions?
I got a question too. Thank you for the talk first. And before the topic changed dramatically from clean architecture to use React, you mentioned a few things that actually bother. First one is button knife, and the second one is clash of APIs. So the button knife forces you to use all your views, even simple text fields, as an instance variables. And the second thing, the clash of APIs, it actually makes your code not so clean, because sometimes you have to use Android APIs, like simple programming, and sometimes Reactive APIs. But doesn't do all these things actually contradict the whole point of clean architecture?
I'll just tell you, our experience has been with butter knife is, in general, it's a big time saver. It saves a lot of kind of boilerplate code problem. We have some best practices on how we use it, right? That kind of make sure that weird things don't happen. I don't necessarily disagree with what you're saying, right? So I won't necessarily disagree. There's trade-offs with all these libraries, right? I was originally hesitant to use butter knife for some of these exact same reasons. One of our other engineers basically really wanted to start using it and convinced me to try it in Call Recorder for me. And we've had no problems with it. It has been very, very easy to work with. Very, very